Okay, so let's take a look at Theorem 6, which is also known as reduction of order. It's basically saying if you know one solution of this second order differential equation here, then you can find the second solution y2 by multiplying the first solution by u, where u is given by this integral stuff here. Okay, so we're going to prove this. So let's start the proof here. Okay, so here's our proof. We're going to start with, we're supposing y1 is the solution of this differential equation up here. And let's find conditions now on this u function such that y2 equal to u times y1 is also a solution of this differential equation. Okay, so let's take the derivative and second derivative of this guy here. So doing that we get then. Okay, so first we'll take the derivative on both sides here. So you'll have our y2 prime equals, we're going to have to use the product rule on this side. So it'll be u prime times y1 plus u times y1 prime. So by product rule. That's next to the second derivative. So we write it here. So doing the second derivative we get then. Okay, so finding y double prime now, we're going to use the product rule on this one. So the derivative of y prime, so that'll be y double prime times, u double prime times y1 plus u prime times derivative of y1, which I have here. So that's our first product rule. Then we're going to use a product rule on this guy. So derivative of u would be u prime times y1 prime, and plus u times derivative of y1 prime, which will be y1 double prime. So that's the product rule here. I guess these two are both the same. We can combine those and make it 2 in the middle here. So let me write it, our result here. So now, so we get this. So now let's assume we're going to assume now that y2 is a solution of this differential equation up here. So let me just note that here. So now y2 equal to u1, y1 is a solution of differential equation implies. So here's a differential equation up here. It's y double prime plus p y prime plus qx y equals 0. Just going to put y2 in place of y here, which I've done down here. So I'll have then y2 double prime plus p of x, y2 prime plus qx, y2 equals 0. Okay, I'm out of space, so let me erase a few things and we'll keep going. Okay, so summarizing, we have this, and here's our y2, y2 prime, y2 double prime. Let's substitute these values in place of y2 double prime, y2 prime, y2 here. So doing that we get then, so making the substitutions then, we get this. Okay, so again, this is my y2 double prime here, this is my y2 prime here, and this is my y2 here. Now I'm going to combine all the u terms. So it's a u term here. Oops. It's a u term here, here, and here. And we have a u prime term here, here. Okay, so let's do that. So combining those, we get then the following. Okay, so rearranging, we get this then. So I pull the u out of this term, this one, and this one. So I got this. Then I also have the u double prime y1 left here. And then I pull the y prime out of this term, and I get this. So I'll have this. And now note here that this part here is 0 because that's just our differential equation evaluated at y1. So this guy is 0. Yeah, so this guy here is 0 since y1 is the solution of differential equation, and this is just the differential equation evaluated at y1. Okay, so then we'll get this then. And now the next part is the reduction of order part. So we're going to make a substitution. So we're going to say let, okay, so we're going to let w equal u prime. So this is the reduction of order part. So that means w prime would equal u double prime. So making a substitution up here, so in place of u double prime, we can write w prime, which I've done here. I'm putting the y1 first here, so it'll be y1 times w prime plus this guy times u prime, but u prime is just w. Okay, now let's divide both sides by y. So doing that, we get then. So I divided both sides by y1. And then notice actually this is a separable differential equation. So let's get all the w primes and w's on one side and all the other stuff on the other side here. So all the p's and the y1s. So let's do that. Okay, so this is a separable differential equation. So moving this guy over here, we get this. And then dividing by w on both sides. So we separate the variables. So we're going to integrate next. So I'm out of space, so let me erase a few things and we'll continue. Okay, so we're to here. Now let's integrate both sides. So integrating both sides, we get then. So integrating both sides with respect to x, we have this then. I broke the integral on this side up into two pieces and I pulled the -2 out of the first guy. So it'll be this and then this. And note over here, w prime is equal to dw dx. I can multiply both sides by dx. So dw would equal w prime times dx. So I can exchange the w prime dx for dw. And same with the dy1 dx equals y1 prime. So dy1 equals y1 prime dx. So I can replace this with dy1. So doing that, we get then. So we get this then, making those substitutions, and the integral of this guy will just be ln of w. This will be ln of y1. So let me write it here. Okay, so we get ln of w equals -2 ln of y1 minus integral of px dx. Now let's bring the -2 up on the exponent on the y1 here. So doing that, we get then. So we get this. Now let's get rid of the ln's by exponentiating both sides with base e. So doing that, we get then. So we get this then. So the e and ln's will cross off here. And let's use properties of exponents over here. Then the e will cross off with the ln here also. Let me write the result here. So we get then w equals y1 to the -2 e to the minus integral of p of x dx. Okay, now recall that w is equal to u prime. Let me just recall that here. So our w is equal to u prime, so therefore we'll have then u prime equals y1 to the -2 e to the minus integral of p of x dx. So we can then solve for u by integrating both sides. So doing that, we get then. So integrating, u then will be integral of u prime dx, which will be integral of y1 to the -2 e to the minus integral of p of x dx dx here. And that's what we're trying to show. So we're done with the theorem. So we're done. Okay, so in the next video, we'll look at some examples of using Theorem 6, or the reduction of order. Okay, so let's leave it there.